This video is going to finish the notes from yesterday, so I'm going to go over example 6, 7, and 8. Starting with example 6. A bag has 5 Skittles and 7 M&Ms in it. If Jesus reaches into the bag and pulls out a candy, replaces it, and then pulls out another candy, find the probability that he will pull out a Skittle and an M&M. So it's important to note that it says that he is going to replace the candy, all right? We want to find the probability of picking a Skittle and the probability of us picking an M&M. The probability of Skittle would be that there are 5 out of 12 total candies in the bag. Since he's going to pick one thing, then put it back, there would still be 12 items left for the second pool, and there are 7 M&Ms in the bag, so we would still be 7 M&Ms in the bag. And means to multiply with probability, so we would be doing 5/12 times 7/12. Use your calculator. You guys can type them in just like fractions, and so you would just type in 5/12 times 7/12 and get your decimal. If you don't have a calculator that does that, you can always multiply straight across. 5 times 7 is 35. 12 times 12 is 144. And now just type that into your calculator. Remember to multiply it by 100 to get the percent. Round to the nearest tenth for me. So when you type that in, multiply by 100, get an answer. You should get 24 3/10%. Abelardo reaches into the bag. He pulls out a candy, but he decides to eat it instead of replacing it. So that's going to change your math here. We want to know what's the probability of Abelardo getting Skittles and then the probability of Skittles, and I would even say after. I would note that that is after the fact because that means one of them has already been taken, all right? So what's the probability of Skittles? Well, there were 5 Skittles to start out of the 12 candies in the bag. And means to multiply with probability. We're getting a smaller chance of this happening because we're listing more criteria to be met, okay? And then what's the probability of Skittles after? Well, if he ate one, we kind of assume that on this first pool right here, on this pool, we assume that he did get Skittles. So if he did get Skittles, how many Skittles would be left? Only 4. And how many candies would be left in the bag? Only 11, okay? Same thing then, multiply straight across. You can use your calculator or you can use your head. 5 times 4 is 20. 11 times 12. Here we go. My 20 wouldn't write is 132. You can reduce that fraction. I'm not really worried about that. I would like to see the percent. But if you reduce it, you should get, oops, sorry about that. You should get 5 over 33. Which is what percent? 15 2/10. The last problem then here, Anushka. Anushka's problem is a little bit more complicated. We're still talking about the same bag of candy, but Anushka, we want to know what's the probability that Anushka will pull out 2 of the same candies. So Anushka could get, what's the probability of getting Skittles and Skittles again, or what's the probability of getting M&Ms and M&Ms again? So we have an or here. All right, so if she can get either one or the other, in the end, you're going to find those 2 probabilities and you're going to add them together. Or means to add, so keep that in mind, okay? We were going to add. But within each event, we have to find the probability. So what's the probability of getting Skittles and then also Skittles again? Well, if the problem doesn't say that she ate it or that she replaced it or that they put it back or they didn't, if you're not sure, I would assume that it's kind of like you're grabbing it at the same time. And if you're picking the candies at the same time, as soon as your hand touches the first candy, the second candy cannot be what you had your hand on first, right? So it's the same as not replacing it, okay? So if you're going to pick out 2 candies at the same time, the probability of Skittles in your first pool would be 5 out of 12, and means to multiply, and we would assume that you got a Skittle on your first one, so you would have 4 Skittles left out of 11. If you recognize that this is the same answer from B, what you got right here, you could just copy that down, all right? But if you don't recognize it, you can multiply it. It doesn't really matter. You're going to use your calculator anyways. So if we did get 20 over 132 for that probability, we now need to find what's the probability of getting M&Ms and M&Ms again. Within this event, and means to multiply. The probability of getting M&Ms on your first pool would be a 7 out of 12. You kind of assume that as soon as you put your hand on the first bag, you got an M&M. How many M&Ms and candies total would be left for the second bag? Well, you'd only have 6 M&Ms left out of 11 total. If you multiply straight across here, 11 times 12, again, 132. 7 times 6, 42. You can use your calculator to add those together. If you're adding fractions, they already have a common denominator. So we would get 132, and then on the bottom, and then on the top we would get 62. Okay? That can be reduced, but we kind of talked about this, guys, with probability. I'm okay with you going straight to the percent. So if you reduce that, you would get 31 out of 66. The percent, if you round to the nearest tenth, is 47%. Make sure you're trying and typing these in on your calculator as well, because some of the practice with probability is actually just learning how to use your calculator. All right, so picking up where we left off, then example 7, Anna has a bin of red, orange, yellow, and green tiles. The number of tiles of each color are shown in the table below. Anna randomly selects one tile, records it, and then returns it to the bin. So again, we've got that point that it is being returned. So that's a good thing to notice and point out. She does this 3 times, so she's going to pick 3 things. I want to know what is the probability that Anna will get an orange tile, and then a green tile, and then a red tile. All right, so she's picking 3 things. Guys, you're going to have 3 fractions. Remember, and in probability means to multiply because you're getting something and something else. In order to find the probability of each of these, we need to know the total. So add up your table right there. 45 and 5 is 50. 50 and 50 plus 25 is 125 total. So that's going to be your denominator here. Since she does return it, take a look at that. She returns it. Since she does return it, we're going to have 125 on the next pool, and we're going to have 125 on the next pool because she always returns whatever she picks. All right, so how many orange are there? Well, there's 45 out of 125 to start. Let's say she does pick an orange. She then puts it back. How many green are there? Well, there's 5 green out of the 125 total. So that would be the probability of green. And then what's the probability of red? It would be 50 out of 125. Okay? You can use your calculator here. You can multiply straight across, or you could just put them all in your calculator. Now, if you look at all of these numbers, they could be reduced. You could take out a 5 out of at least every single fraction, probably even more, maybe even 25 on some of them. But you don't have to do that for me. If you want to, that's great. That's extra practice. If I multiply straight across, I could even just go straight to the fact that we would then times by 100 to get the percent. Do this for me on your calculator and get a percent. While I'm talking, I want you to do that. So you are making a very specific case here. We want to know what's the chance of her getting orange and green and red. Because you're being so specific, your chances of this happening is probably very small. So when you multiply, don't be alarmed if you get a very small decimal. Don't be alarmed if you get a decimal even after you multiply by 100, and that's your percent. So hopefully by now you've typed this in on your calculator, and what do we get? I got 0.576, which would be, if we round to the nearest tenth, about 6% probability. So, about 0.6, 0.6%. So you have a less than a 1% chance of getting orange, then green, and red. Very small chance because you're being so specific. Okay, so moving on, we're going to go down to example 8. The first thing I want to talk about example 8, if you did these already without me, you're going to have to make a change because there is a typo on this problem, okay? So I want you to change this probability right here. 7/13, I think it was just a typo. It doesn't really make sense. I'm going to change it to 6/15, and I'll tell you why as we get into the problem. But right now, just change that, please, to 6/15. Make sure you notice that difference there, okay? All right, so Jaron rolls a special 15-sided die as an experiment. Some information about the die is written below. We know that there's a 1/5 chance that a probability, 1/5 probability, that Jaron will roll a number that is a multiple of 5, and there is a 6 out of 15 chance or probability that Jaron will roll a number that is prime. We want to know, Jaron rolls his 15-sided die 2 times. We want to know what is the probability that he rolls a multiple of 5. So we want to know the probability of getting a multiple of 5 on the first roll, and the probability that he does not roll a prime on the second one. Alright, so we don't really need to know exactly what numbers are on our die to do this problem, because the probabilities they give you will help you. But if you think about the die, if it has 15 sides, there's probably 1, 2, 3, 4, pen's not working very well, I'm sorry, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 on the sides. Now, it may not be those numbers, but just to show you with those numbers, would it make sense for there to be a probability of 1/5 that he would get a multiple of 5? Well, 5 is a multiple of 5, 10 is a multiple of 5, and 15 is a multiple of 5, right? So that does make sense, because 3 out of 15 sides of the die would be a multiple of 10, a multiple of 5, and 3 out of 15 reduces to 1/5. Would it make sense on this one that the probability that Jaron would roll a number that is prime would be 6 out of 15? This is why I changed the numbers. Well, let's think about it. What are the prime numbers? 1 is not prime. 1 is neither prime or composite, okay? 2 is a prime number. 3 is a prime number. 5 is a prime number. Prime means that it's only divisible by 1 and itself. So we would also have 7, 8, 9, and 10 would not be considered prime. 11, not 12, 13, not 14, and not 15. So we would have, count those, we would have 1, 2, 3, 4, 5, 6 numbers out of the 15 total that are prime. So that's why I changed this number here, because I think that we should have that, okay? Alright, so if we want to know what's the probability of getting both of these things, and means to multiply. The multiple of 5 would be a 1/5. We have a 1 out of 5 chance, because they gave that to us. Now don't get tricked by this not prime over here. What's the probability that it will not be prime? Well, keep in mind they gave you the probability of prime. So what does this mean? This means there are 6 prime numbers out of the 15 total. If 6 numbers are prime, how many are left to get to the total that would not be prime, right? Well, so if 6 numbers are prime, how many numbers are left to not be prime? Well, 15 minus 6 is 9, right? So that would leave 9 numbers that are not prime out of the 15 total, okay? Perfect, so now we just multiply them. You could reduce the numbers. If you don't want to use your calculator as much, 9 15ths can reduce. We can take a 3 out of both of those. 9 divided by 3 is 3. 15 divided by 3 is 5. And we could multiply straight across here. 1 times 3 is 3. 5 times 5 is 25. 3/25 equals what percent? When you divide 3 by 25 and then multiply by 100, you should get 12%. And even if you didn't reduce the fraction, if you just type this in your calculator, 1/5 times 9/15 should still give you 12%. So hopefully that helps you to finish your notes and complete examples 6, 7, and 8. And if you have any questions on this, please let me know.